Okay, welcome everyone. Today we're gonna cover compression. So compression is basically reducing a file size of a file. So if I have a video and it is 500 MB and I believe it is too large for a video file, if I use some mathematical equations and all and convert and reduce the number of bits it has without reducing the quality, I do compression. And with this mathematical formula, if we could reduce it to 500 MB, we've reduced the file size by 50%. But this is just the tip of an iceberg. Um, so according to this syllabus, you must have idea about two types of compression. One is lossless, another is lossy. So please deduce the meaning of the compression. These both of them are a type of compression, and deduce the meaning of the compression from the word itself, lossless. There is no loss of information here. In lossy, there is loss of information. Right. So, I will give you an example. Let's talk about lossless first. And I will also help you give a proper definition. So, the book from Horda has a very good definition. If you can, please screenshot this section. So, lossless file compression, the file compression method where the original file can be restored following decompression. So, I've compressed the file, I've sent it to the user, and the user feels, the receiving end feels, they want to decompress the file, they can do it, and no information will be lost in that process. But in the lossy file compression, the parts of the original file cannot be recovered during decompression, so some of the original details might be lost. Let's go in depth with some examples. So, how many of you have an idea about the human hearing range? Human hearing range ranges from 20 Hz to 20 kilohertz. Suppose there is a sound wave. So animals have different range. Dogs have more than us. This is a recorded sound wave. Now, anything above this range is basically not audible for me. So why do I even bother keeping the data or information beyond these two ranges? This is where lossless comes in play. So we just delete these paths and send given and also we know in order to store these paths, computer has definitely utilized bits to store these paths. So this section is gone, this section is gone, right? We don't have this, we don't have this. So the number of bits required to store this audio information or mechanical wave is also reduced. This results in a decreased file size, but the information is lost and we cannot retrieve the information back. This is why it is called lossy compression. Another example of image could also be used. Imagine you want to see a image in a 4K in a full HD screen. Full HD screen has a resolution of 1090 by 1280, let's say, and you captured the image in 2K, 2560 into 1280. Let's do a thing, 2560 into 1600. This is the resolution you captured your image in. There is no point of this high resolution if you plan to open the file in this resolution. So you could decrease the resolution and save a lot of space. This could be an example of lossy compression in an image. So it's not retrievable. You cannot retrieve the original file back. Now let's talk about this is all about lossy compression. Now if I had to talk about lossless compression, um, lossless, so there is no loss. Example includes run length encoding. So I have a text file which looks like this. Right. Now run length encoding basically uh, counts the number of times a particular digit or a bit or let's say character has been repeated, and it reduces this into a concrete form. For example, A has been repeated 3 times, right? So we write 3A. F has been repeated 2 times, 2A, 3A, 1, 2, 3, 4, 5, 5G, 5C. This is an example of run length encoding. A similar process or method can be applied for images as well. Imagine this is a file frame with a black background itself, and there is a picture of a person who is playing with a football. So all the background, most of the part of the background is black, and the hex code for a black is, let's say, FFFFFF. It's either 0000 or FFFF. And let's assume the number of pixels of black is 1000. So it encodes this part as this, and all the other parts remain the same. This is a lossless compression, and if I want to get the original image back, it just does the inverse of a formula, and all the bits are in places. So it can go here, it can go from here to here, and here to here as well. This is how a run length encoding works. So perpetual music shaping, methods where sounds outside the normal range of hearing for humans are eliminated, which I talked about. Audio compression, so basically how we compress it using perpetual music shaping. And so all the extensions which we commonly see in our videos, such as MP3, MP4, MP3 is usually for music, MP4 is for video, are all compressed file formats. MP3 is a sound file of a compressed after compression. What do you think is a file, audio file that is not compressed? What's its format or extension? It's .wav, right? JPEG is for a compressed image file. So this is what I talked about. So A has been repeated 5 times, 05, and it's 97 because the lowercase ASCII code of A is 97. It's same for B. Sometimes, let's say for example, this is where students can make mistakes. We have this. We also have E. So for E, we cannot just write E. We need to write 01, and E would be 101. Okay. If exam, okay, it's done here. For bitmap image, this is how it's done. 9 white, right? 1, 2, 3, 4, 5, 6, 7, 8. So it's not. It's doing in this order. So it's keeping it's organizing in terms of rows. So 9 white, 6 black. So according to the F marker. So you don't need to calculate it for the file, but make sure you know how it's done. So this is how compression is carried out. Movie files, so how do they compress it? They reduce the sampling rate, they reduce the sampling resolution, they reduce the frame rate. Images, they crop the image. Yes, cropping the image is also another way to do a lossy compression. So you're losing the details from the original file. You could also decrease the color bit depth. You could reduce the image resolution. All of these, most of them are lossy compression methods. So this video concludes our part 1 of the syllabus, or chapter 1 of our computer science syllabus. I hope you had a wonderful time learning about the theories of information exchange, information system, images, videos, audios, compression. Thank you so much. Stay tuned for new videos. Bye bye.